tayong bagong project. Ay, ano na naman yan? Oh, to. Ito ay tinatawag na OR gate. Ay, ano naman ang yan? Ha? Gamitan natin ng supply power bank para malaman natin kung paano ito gumana. Lagay natin. Okay. Oh. Tama yan. Umilaw na yung pulang LED. Yan ay power LED. At meron ditong blue. Yan ay output LED. Yung yellow at green, input LED. Switch 1, switch 2. At may ginamit tayo ditong IC. Yung 7432. Meron din mga resistor, jumper wires, breadboard, push button. Di ba, ha? Eh, paano naman yung gumana? Ha? Ha? Oh, ito yung OR gate. Ang OR gate ay isang switching circuit. Switching circuit sa electronics. Pag pinindot ko yung unang switch, umiilaw yung output. Diba? At yung input LED. Kada pindot mo, yun, oh. Yung kabila switch, umiilaw din yung output. Ibig sabihin, may output. At yung green, umiilaw din. Ibig sabihin, pinindot yung switch 2. Pero pag sabay kong pinindot yan, umiilaw din yung output. Tsaka mga input. Yan ang OR gate. This is the schematic diagram of the OR gate. That is the diagram of the circuit we tested. For our circuit, we have this 5-volt supply from the power bank. And then we have two switches, push button switch, a tactile switch, switch 1, switch 2. And into the switch 1, we have this input LED, yellow for the switch 1, with a current limiting resistor of 1.5K. And to the LED yellow to the ground. And to the switch 2, we connected the another input LED, D2 green, with a current limiter resistor of 120 ohms. We also have this power LED so that we know that the circuit is on. Once we powering on the circuit, the power LED turns on. That is color red LED. With a current limiting resistor, in order not to burn this LED, 3.9K ohms. And this is now the OR gate. What is the use of an OR gate? Is it just a gate? OR gate is used for switching application in electronics. OR gate consists of two inputs with one output. And the result of the two inputs can be verified using a truth table. Into the output of the OR gate, we have this output LED blue with a current limiting resistor of 3.3K. The main operation of an OR gate is we are using this truth table. And why is it that we have this truth table with letters A, B, Y? Why we have these letters? This A represents the input. Input 1, A. And then B, input 2. We have two inputs with Y, the output. And then into the truth table, we have this 0 and 1. What does this 0 and 1 represents? 0 represent a low level or low logic level or off condition or low logic, low level voltage or ground. And 1 represents a high level logic or on state, or in our case here could be a 5 volts. So as we have see here in the truth table, if A is 0, A represents 1. Why is it 1? In this with this schematic diagram of OR gate, why is it 1 here, 2, and 3? These 1, 2, 3 numbers that is derives from this IC pin out of 7432 OR gate. Since we are using the IC 7432 OR gate, this type of IC has 4 OR gate. And then pin number 7 is the ground. Pin number 14 is the BCC, supply of the IC. And we are only using 1 OR gate. Since this is a 4 OR gate inside the IC of this 7432 IC. You can see here the pin out. 1, 2, the input of the first OR gate. 3, output. 4, 5, inputs. Second OR gate. 6, output. 7, ground. 8, output of the third. 9, 10, input of the third OR gate. Fourth OR gate. 11, output. 12, 13, input. And then 14, BCC. So you can see here, 1, 2, 3 came from, or that is why we have this 1, 2, 3 into our schematic diagram from this pin out of 7432 OR gate IC. So we are now clear that 1, 2, 3 came from 1, 2, 3 of the pin out of 7432. When we did not press the switch of the switch 1, switch 2, we are repairing that the switch 1, which is A, is 0 and B 0. So the input terminal of an OR gate is connected to the ground. Switch 2, which is B, input connected to the ground via these two LED. So they are both 0. And because of that, there's no output. So the blue LED will not turn on because two inputs are grounded. Why? Because the switch is open. Only the power LED turns on. The moment that we press the switch, as you can see in the truth table, what is the use of the truth table? To know the situation or the condition of our circuit. If switch A is 0, we are repairing switch A to this terminal. 1, 0. It means it is grounded. There's no input. And switch B is 1. It means we are pressing the switch 2, repairing to B, the pin 2 of the OR gate, the B here in our truth table. Switching on this switch, pressing this switch on, it will make the current to flow into the LED green, turning this LED green on. What happened to the output? If we have one input, okay, the current flows into the 5 volts into the LED and injecting current to the pin number 2 or B. It will turn on the output. So that's why in our Y, which is the pin number 3, the output side of the OR gate is 1, a high logic level, or it means it is on. There are only 2 logic or logic level in digital electronics, only 0 and 1, or in computer, it reads only an on and off condition. 1 refers to the on condition. It means 1 on, LED green turns on, and then 1 to the output on, LED blue turns on. So the moment we press the switch 1, switch 2, every time we have an input, at least one of the switch, for the switch 2, it will turn on the output. In the case that the switch 1 now, or A, is now on, we are sending current to the yellow LED through via 5 volts, then switching this switch on, and then to the ground, to this LED resistor to the ground, injecting current to the 1, making this terminal 1, which is A, to turn on 1. What is the output? And then we have the input switch to 0. It means it is grounded. We did not press the switch. The output will be 1, or it will turn on the output. LED blue turns on because we're having a 1 input. And then if we both press the switch, it will turn on the output. So the use of the OR gate is for switching application. Whenever we encounter a switching circuit that has at least 2 inputs, and then we are dealing with only 1 output, any combination of the switches can be notified or can be verified with the use of truth table. There can be a case that there is a 3 input OR gate, or so on and so forth. In our case, we have only 2 input. So when we have 2 switch and we need to know the result of the output, if any of the input switch, whenever at least one of the input LED turns on, it will produce an output of 1, or it will turn on the output. You can see in the truth table. At least with the 2 switches, at least one of the input turns on. It could be switch 1 or switch 2, A or B. The output turns on. Or both of them, when we press the switch, both of them, it will turn on the output. So in that case, that kind of circuit, switching circuit, is called an OR gate.